Good day everyone, my name is Graphics. Now if you look at the front of your screen, you see a question that is displayed there on fluid mechanics. And the question goes like this. It says calculate the density, specific gravity, specific volume, specific weight, and mass of the air in a refrigerator whose dimensions are 3 meter by 5 meter by 7 meter at a standard temperature 25 degrees Celsius and pressure of 100 kilopascal. Now, solution. If you see a question like I usually tell people or my students that the first thing you have to do is to write out your data, or you call it the parameter, or you call it the givens. Now, since it says calculate the density, it means the density is unknown, right? The specific gravity is also unknown. The specific weight is also unknown, and the mass is unknown, right? Of the air in the refrigerator whose dimensions are, so we have 3 by 5 by 7, that is the length of the fridge. You're talking about dimension of the fridge now. The refrigerator is 3, the breadth is 5 meter, and the height is 7 meter. Now, since these three parameters are given here, means you can calculate for the volume. So our volume will give me the length times the breadth times the height, which is giving us what? 3 times 5 times 7. That will be equals to 105 meter cube. Now the next thing given here is the temperature. The temperature is given as 25 degrees Celsius. Now you have to convert it to Kelvin. How can you convert to Kelvin? Is by adding the figure in degrees Celsius by 273. So if I add 25 plus 273 to give me my value in Kelvin, which is 298 Kelvin. Now the next thing we have there is a pressure. The pressure given is 100 kilopascal. Now there's one parameter there that is not given, but you have to know it. And what is the parameter? Since we're dealing with air, so we have what is called the specific gas constant R, and that will be giving us 0.287 kilojoule per kilogram Kelvin. Now, the first to calculate for is the density. So calculating for density. Recall, with our ideal gas, the specific condition, air can be treated as an ideal gas, right? So for an ideal gas, we say that the mass times the gas constant R times T is equals to what? Pressure times volume. So I'll call that my equation 1. Now, if you divide both sides of the equation, I mean the right hand side and the left hand side of the equation, by the volume, you'll be having this, which says the mass times the R times T all over V, that's on the left hand side, is equals to the pressure times the volume over V. Now we have this. Now if this V at the right hand side here would equate each other, and we'll be left with the mass over the volume times the R, which is the gas constant, times T is equals to what? The P, which is the pressure. Now let me name this equation 2. Now in equation 2, but the mass over volume is given as what? Density. If you recall, density is what? Mass over volume. Now if you input the density into equation 2, we'll be left having what? The density times the R, which is the gas constant, times the temperature equals to what? The pressure. I'll call, now you make the density the product of the formula. Now density now will now give me, how will you do that? You are going to divide both sides by what? By RT. Now divide both sides by RT, you'll be having the density times RT divided by RT equals to what? The pressure over RT. Now the RT, we put the RT in the left hand side, and we're having density is equals to what? Pressure over what? The R times T. Now if you put your parameters, your data, density will now be equals to the pressure is 100 all over the gas constant is 0.287 times the temperature, which is in Kelvin, that is 298, and that will give us 1.169 kilogram per meter cube. Now the next thing we calculate for is calculating for the specific gravity. Now we know that the specific gravity, since we are dealing with air, right, so we mean the density of air is 1.169 kilogram per meter cube. So like I said, calculating for specific gravity, so specific gravity of air will be equals to what? The density of air over what? The density of water. Now what is the density of air? It is what we just get here, and that is 1.169 over density of water, which is 1000. That will be equals to 0.001169. Specific gravity doesn't have a unit, it is dimensionless. Now the next thing we calculate for is calculating for specific volume. We know, recall that the specific volume is equals to what? 1 over density. Watch the previous video, you get to understand how we got this formula. And this will give us 1 all over the density of the air is 1.169, and that is equals to what? 0.855 meter cube per kilogram. Now the next thing we do is calculating for the specific weight. Recall, specific weight is giving us the density of the air times the gravity. Now the density of the air is 1.169, right, times the gravity, which is 9.81. And what we'll do when we multiply these two, we're having 11.468 Newton per meter cube. The last but not the least is to calculate for what? The mass. Now recall that the density is equals to what? The mass over the volume. Now what is density of the air given? And that is what? 1.169 over equals to the mass all over what? 105, which is the volume. So if I cross multiply, the mass will now be giving us 1.169 times 105, and the mass will be equals to what? 122.75 kilogram. So this is the mass of the air given. So if you found this video helpful, please don't forget to click on the subscribe button, and also don't forget to click on the like button. Thanks for watching.